Hi there. In this video I'm going to show you give you a quick introduction to the vector product. So just to remind you, we've had different types of products and multiplications to do with vectors so far. We've looked at multiplying vectors by a scalar. I remind you that that gives you a vector that's parallel to the original one. We've had the scalar product, or the dot product as we've been calling it, and that gives us a value, a scalar, in this case a numerical value of 5, and I remind you that that's really useful for finding the angle between two vectors. But what I'm going to look at now is a different type of product. So we're multiplying vectors together in a different way, and the result of it will be a vector. Now here's the rather complicated looking formula. Well, it's complicated looking for the first time, but you'll get used to it and it's not really too difficult to use. So if this is a vector in 3 dimensions and a second one here in 3 dimensions, and actually that's quite important because the vector product in 2 dimensions doesn't exist at all, it wouldn't make any sense. Then the cross product, or the vector product as that's written there, gives us something quite interesting. It gives us a vector that's perpendicular to both the A and the vector B, and that's going to be really useful for us later on when we start looking at perpendicular vectors and in particular the equations of planes. So here's the formula. So if we write it down like that, then we will see that the vector product is this one here. So as I said, it looks complicated first time round. Here's my way of trying to remember that visually. So let's try and work out the first line or the first entry in this vector. So I'm going to cross those two off there, and I'm going to work out A2 times B3, and I'm going to subtract A3 times B2. You can see it makes a nice little square there. A2 B3 minus A3 B2. So that's the first entry. Now let's try and do the second one. So cross out the second row. I'm going to try and find this entry here, and what I want is A1 times B3 subtract A3 times B1. Now what you're thinking is, well, that's actually not the same as what we've got here. In fact, it's the negative of that, so that's something to work out, and you could write that of course as A3 B1 times A1 B3, but personally I like to think of it as the negative of the left to right calculation that we did for the previous one. And then the third entry, cross out the third row, and then you work out A1 B2 subtract A2 B1, and that's there. Okay, so first couple of times it is something tricky to remember, but actually it's not anything that you need to remember at all because that's in the formula booklet. And I'd ask you to pause the video right now and go and try and find that. Okay, back again. So hopefully you found that in the formula booklet, and it looks in a similar, although not exactly the same format as that, and you'll be able to refer to that at any time and use it. Now then, you might have also seen in the formula booklet that there was a second equation for the vector product, A cross B here. Notice that we've got these in bold type to represent vectors, and that is this value here. So here we've got the magnitude of A, the magnitude of B, the sine of an angle between the two vectors, and then we've got a vector here n hat, which is a unit vector that is perpendicular to both these two. Alright, so that really does seem quite complicated, but that has got some use when we start looking at angles between vectors, but in particular we're going to use that formula for finding the area of a triangle, and we'll come back to that in another lecture. So we're interested more in this formula here. Now actually, if you look at your textbook, you might even see that there is another formula, and this one here involves using matrices. Now matrices used to be on the IB higher level course, but no longer is, so that's not really an appropriate method to use anymore. But I'm just showing you that now because if you look in your textbooks you may see that one. Right then, so let's get down and start using it. So here's an example. Here's a vector, again just to remind you that needs to be in 3 dimensions, this one here in 3 dimensions, and I want to find the vector product, the cross product, and that's going to give me a vector. So let's try and do that now. So let's set it up. 2, 3, minus 1, minus 1, 2, 4. Now what I would say is that you do have to be quite careful with this calculation. It is very, very easy to go wrong. So let's start off with the first entry. So as I said before, I'm going to highlight that one there or cross it out and then concentrate on the 4 entries that are left here, and I'm going to work out 3 times 4 subtract minus 1 times 2. So that's 3 times 4 subtract minus 1 times 2. Okay, and then the second one, so let's cross out this row here. Now I'm going to do, as I said, I prefer doing the negative of this value, so I'll do 2 times 4 subtract minus 1 times minus 1. Okay, and you can see there the potential for really going wrong with your positives and negatives. We'll come back to that. And then the third row, let's cross this off. Try that one again. Let's cross this off and then do the same calculation again. So 2 times 2 subtract 3 times minus 1. I'm going to just do that straight away. So 4 plus 3 is 7. Okay, so let's work those out. So 12 plus 2 is 14. 8 subtract, there we go, you've got so many negatives here, it's so much potential to go wrong. We've got minus 1 times minus 1 is plus 1, so we're subtracting 1, so that's 7, but it becomes negative. There we go, and then the last one that I've worked out is already 7. Okay, so there we are. So a lot of care required to get that right, and I left on a previous calculation that I'd put in IJs and K notation because I thought I might easily go wrong. Now I'll come into a minute a way of checking that. The fact that you get perpendicular vector, we can use the dot product to do some checking. Now I'm quite interested in seeing what that looks like. So let's go back to the first 2 vectors. So the vector in red there is the first vector A, and the vector in purple is the vector B. Now what we're going to do, I'm going to get Autograph to try and work out the vector product for me. So I'll highlight those 2, you can do this yourselves, and then right click. So let me just go through that again. So I clicked on the first one. Actually the order is really important with this. Click on the first one, then the second one, then the point in between. Now those vectors could be anywhere, I've just put them together to help us make this calculation on Autograph. And then it will work out for me the cross product. Put that in there, and can you see there's a green vector that it's created. Now it's not completely obvious from that is perpendicular to the first 2, but what I'm going to do is I'm going to put a plane through these 3 points here, and hopefully that should help our eyes a little bit. So those 2 original vectors are lying on that plane there. Actually I'll tell you what I'll do, I'll put this in a file to share with you and you can play with it yourselves. Those 2 original vectors here are lying on the plane, and it should be, yeah, I can see that one there, the green one, is now perpendicular to that. Okay, so that's pretty useful. Now I just want to show you something, what happens if you don't get the order right. So let's just get rid of that. So I've got the original two vectors sitting on a plane. So let's do B cross A this time. So I'm highlighting those two and then the point, and let's do the cross product, and there's nothing there. So where is it? Well, it's actually on the other side. Okay, so it's exactly the same vector, but it's negative. So that's key, and that's the reason that you've got to get the order right with this. Okay, so for the dot product that we worked out before, the order didn't matter. For the vector product, it's critical. Right, and we'll look at a way of trying to remember what that means in a second. So there we go. The vector, that result I've got there is 14i minus 7j plus 7k. And that's what we've got. Now then, a right-hand rule. Now that, for you as physicists, that right-hand rule, or you may even heard of another one, a left-hand rule, but the right-hand rule is the one we're going to use here, is useful for working out the directions of the resultant vector or the vector product. Okay, so what you do is this. If you take your finger direction as the direction of the first vector, so that's that red one, and then if you take your second finger direction as the vector direction of the second one, then the direction of the final one, so that's coming out of the page in this case, not going in as I got them the other way around, then your thumb will give you that direction. Okay, so try this now. I'm sure you've done it in physics. So get your finger to point in the direction of the red one, get your first finger, that is. Oh, I just got that wrong. Yeah, I realise I've got that wrong. It's actually your thumb. Okay, so ignore the last 1 minute. Let's go back and do that again. Let's try that again. So it's actually your thumb that is giving you the first vector direction. Whoops, I'm struggling here with the colours. So your thumb is the first direction, so that's the red one. Your first finger is the second one, so that's B, and then your second finger is the vector product. So try again now. So get your thumb to point along the red line, your first finger on the purple, and then hopefully you'll see that your first finger is pointing up at you now. I'm doing this in front of the screen. And just try doing that the other way. So make it so that B cross A is what you want to work out. So your thumb should be pointing in the direction of this purple one, your first finger the red one, and then you see that you have to twist your hand round and that your second finger is pointing into the page. Okay, so that's pretty useful for working out the directions. Now, as I said, it's easy to go wrong here with this calculation, but there is a way of checking it, and the way of checking it is the fact that the vector product, as we said, should be perpendicular to the first two vectors. So if it's perpendicular to the first two vectors, then the dot product of one of the first vectors with the result should be 0. We know that dot product of two vectors that are perpendicular is 0, so that's really useful. So let's just show you how that works here. If I take the result we've got there, 14 minus 7, 7, and I work out the dot product of, well, let's just try A, 2, 3, minus 1, then we get 14 times 2 is 28, minus 7 times 3 is minus 21, and 7 times minus 1 is minus 7, which gives us 0. If I get 0 there, I think great, I've got that right. Now it might be worthwhile checking it with the second one, so let's just see that that works as well. Okay, so I get minus 14 plus 28, and of course that's 0. Okay, and actually that's what the vector product is. It's a vector that will give you a perpendicular to the two original vectors. In other words, it's a vector that will give you a dot product of 0 for the two vectors. Now without that formula that would have been pretty tricky to work out, but somebody's done it for us, thankfully, and now we can just use it. So whenever you do a calculation and you're working out the vector product as we've done here, you really should be doing the dot product for at least one of them. It doesn't take long, but that's a good way of checking that. Okay, so here's another example. First of all, applications. So we've talked about the right hand rule there, and you might have come across that in physics to talk about a magnetic field in a coil of wire, the directions for that. And my physics is a bit rusty, but I do remember doing that in physics, and I'm sure you come across it as well. And there are other applications of that as well that you may have seen. Right, so let's try this one. What we're trying to do in this example then is to find the vector of magnitude 5 units that's perpendicular to both A and B. So we can find a vector that's perpendicular to A and B by finding the vector product. Then what we've got to do is adjust that vector so that it has a magnitude of 5. Okay, so what I invite you to do now is to try to work out the vector product of A and B. So pause the video and then we can check that work. Okay, got that? Well, I've not, and I can see that I've made a mistake here, and I just thought this was worthwhile showing you. I've tried to do the vector product. I've got something that's I can see here is not the right answer, because I've done the dot product with the vector product, and I've got an answer that's not 0. So I can see here that that's not correct. Right, so I just thought that was worthwhile showing you to see what you get if you don't get the right answer. So unfortunately I've got to do that all again now, so be patient. Okay, so I've had another go at that, and I've got 2 minus 1, 5. I've checked it. The dot product with that and the first vector is 0, so I'm pretty confident that I've got that right. So that should be the correct answer for a vector that's perpendicular to these two. Now then, what we're asked for is a vector that's perpendicular but has a magnitude of 5. Right, so I'll remind you how to find the magnitude of a vector. We need to use Pythagoras' theorem. So let's work out the magnitude of this one. So I want to find the magnitude of 2 minus 1, 5. So we have, well, we're going to get the square root of 2 squared plus minus 1 squared plus 5 squared. Okay. So that's root 30, isn't it? So this vector here has got a magnitude of root 30. If we want it to have a magnitude of 5, then we need to multiply it by something to bring it into the right size. So remind you about unit vectors. If you want to find a unit vector, what you need to do is divide a vector by its magnitude, and that's what we're going to do here. But that will give us a vector of magnitude 1, and what we want, of course, is a magnitude of 5. So we take our vector, divide by root 30, and then times it by 5, and that gives us this answer that we've got here. Okay, so I'll allow you to finish that off. Pause again the video to do that. Now then, the last question I want you to try and do at the end of this lesson is to answer this one here, and I'm going to explain how to do it, and then I'm going to put just the answer for you up for you to try and do. So what we've got to do is find a unit vector that is perpendicular to the plane containing the points A, B and C. So we've got those coordinates there of A, B and C. So it always helps me to have a little diagram there to be able to visualize that. There's A, there's B, there's C within a plane. That's how you define a plane with 3 points. And what we want is a vector, a unit vector, and that is the notation that we use for that. It's perpendicular to those 3 points, or it's perpendicular to that plane, and it's got a length of 1. Okay, so then how are we going to do it? pause the video and just think about that, maybe discuss it amongst yourselves. Okay, so how we do it is we find two vectors, AB and another vector which we could do AC, although we could do a different one if we wanted to, and then we work out the cross product of those two vectors there. Okay, so if we work out AB, if we work out AC and work out the cross product of them, then we will get a vector that's perpendicular to the plane, and then we need to make a unit vector. Okay, so pause the video, try and do that yourself, and then I'll come back with the answer. Okay, so here we are. Those are the two vectors AB and AC. That's our vector product there. I've checked it, and I've checked it with 2 here just to be doubly sure. That's given me a dot product of 0 with the first one. That's given me a dot product of 0 with the second one. So I'm happy that I've got the correct answer for this. That's the vector product of those two. Remind you, that's giving me a perpendicular vector to the two vectors AB and AC. Now what I've got to do is I've got to make that a unit vector. So I need to find out the length of that and then divide the answer, or that vector, by that value. The length of it is root 150, so that's my answer there. Okay, so I think that'll do for us today. Next lesson I'll show you a little bit more about that in applying it, and also we'll have a look at the other formula. Okay, good luck with that.